Section 3-1, Solving Systems by Graphing. A system of equations is a set of two or more equations. In this section, we are only going to be looking at linear systems, and those are systems that consist of linear equations, which are just a bunch of lines. A solution to the system is a set of values for the variable that makes all equations true. There are two types of systems. The first type that we're going to look at is a consistent system. All consistent systems have at least one solution. Inside of a consistent system is an independent system, and an independent system specifically has one solution. So again, an independent system just has one solution. Also inside of consistent systems are dependent systems, and those have infinitely many solutions. The other type of system is an inconsistent system, and that is going to have no solution. Now let's see what these systems look like graphically. When two lines intersect at one point, this means they are going to have one solution. Since I have one solution, which means I'm going to have one answer, this is going to be an independent system. If I have two lines that are the exact same line, this means there's going to be infinite solutions, which would make this a dependent system. If I have two lines that are parallel, those parallel lines are never going to intersect, which means I'm going to have no solution. And no solution makes this an inconsistent system. Let's look at our first example, and we are going to be solving by graphing. So our system is x minus 2y equals 4 and 3x plus y equals 5. So I need to take my two equations that they give us, and we need to put them in slope-intercept form so that we can graph them. So to move positive x to the other side, I need to subtract it. So that gives me negative 2y equals, and make sure you write your x first because you want it in slope-intercept form. And then I divide by negative 2, which makes this y equals, a negative divided by a negative is a positive 1/2 x. 4 divided by negative 2 is negative 2. Now let's take the second equation that was given to us, which is 3x plus y equals 5. And again, I'm trying to put it in slope-intercept form, so to move positive 3x to the other side, I'm going to subtract it. So that gives me y equals, write your x term first, so negative 3x plus 5. Okay, so let's make a graph. X-axis, y-axis, okay, and we are going to first start with y equals negative or positive 1/2 x minus 2. So I need to put a dot at negative 2 on my y-axis, and then my slope is 1/2, so that means I rise 1 and I go to the right 2. And you want to keep doing this a couple of times because you're trying to get a precise line. So I'm going to rise 1 again, and I'm going to run 2. You might want to go down 1 and to the left 2 to continue this line. And connect all your dots. This is going to be done the easiest through graph paper, so you guys might want to start bringing your graph paper to school next week. Alright, now let's graph y equals negative 3x plus 5. So this time I put a dot at positive 5 on my y-axis. 1, 2, 3, 4, 5. And then my rise is now -3, so 1, 2, 3, and it's a run of that invisible 1 that's under that 3. So then go down 1, 2, 3, and to the right one, and look, I found a point where they intersect at, and that is my answer to my system. This is an independent system because I have a point of intersection. And the answer to my system is 2, -1, since that's where that point where both lines intersect is at. Our second example, I want you guys to press pause and I want you to solve. Again, remember you are solving by graphing, so make sure both of your lines are in slope-intercept form. I'm going to take my first equation, which is -3x plus 2y equals 8, and I'm trying to get it in slope-intercept form, so to move -3x to the other side, I need to add 3x. So that gives me 2y equals, write your x term first, and then to get rid of my 2, I must divide everything by 2. So that gives me y equals, keep it as 3/2 x because now I know my rise over my run, and 8 divided by 2 gives me 4. Now let's take our second equation, which is x plus 2y equals -8. To move positive x to the other side, we need to subtract it. So that gives me 2y equals -x minus 8, since it was already negative. To get rid of my 2, I divide everything by 2. So that gives me y equals -1/2 x minus 4. Okay, so now let's draw a graph, and we need to be really precise with our graph. So for our first line, we're going to graph y equals 3/2 x plus 4. So I need to put a dot at +4 on my y-axis. And then since it's +3/2, I would go up 3, and I would run 2. Now you are going to keep doing these points over and over and over again because you don't know where the point of intersection is going to be. So I'm going to go up 3 more, and I'm going to run 2. To get some points going the other way, I'm going to go down 1, 2, 3, and I'm going to go to the left 2. Down 1, 2, 3, left 2 more. Okay, and I'm hoping that those are enough points. Worst case scenario, I can come back through and I can add some more. Okay, so now I'm going to graph my second line, y equals -1/2 x minus 4, so I put a dot at -4. Since my slope is -1/2, I go down 1 and I go to the right 2. However, I hope you notice that if I keep making my points this way, it's not going to help me intersect with my pink line, so I'm going to go up 1 and I'm going to go to the left 2. Okay, getting a little better. Go up 1, go to the left 2, and look, my 2 lines intersect at this nice point right here. So the answer to my system is -4, -2. That's where my 2 lines intersect. And this is an independent system since they have one point of intersection. Now let's look at how we are going to classify our systems without graphing it every single time. So example 3. So we have -3x plus y equals 4 and x minus 1/3 y equals 1. So we're going to take our 2 equations and we need to put them in slope-intercept form, even though we are not going to graph these. So to move -3 to the other side, we add 3x. Please remember that you can't combine numbers and variables, so I'm just going to write my +3x first, and then +4 since 4 was positive, okay? So the first equation we have in slope-intercept form, so now let's take the second equation, which is x minus 1/3 y equals +1. So to move positive x to the other side, I need to subtract it. So that gives me -1/3 y equals -x plus 1. So now I want you to think back to when we did put our equations into standard form, because I know you guys are really not liking that 1/3 that I have going on. So I need to get rid of my 3 that's in the denominator. So to get rid of that 3, I'm going to multiply the entire equation by 3. But then I hope that you notice that this equation has a negative in front of it, so I'm not just going to multiply by 3, I'm going to multiply by -3. So -3 times -1/3 y gives me just positive y. And then -3 times -x gives me positive 3x. And -3 times positive 1 gives me -3. And now my two equations are in slope-intercept form. I have y equals 3x plus 4 and y equals 3x minus 3. And I hope you're sitting here and you are noticing that they both have the exact same slope, that they both have a 3 in front of the x. But their y-intercepts are different, positive 4 and -3. So two lines that have the same slope are considered to be parallel lines. And we know that parallel lines are never going to intersect, so this is an inconsistent system. In example 4, I want you to press pause and I want you to classify this system as either being independent, dependent, or inconsistent. So we have to put our two equations in slope-intercept form. So I have 2x plus 3y equals positive 1. So to move positive 2x to the other side, I need to subtract 2x. So that gives me 3y equals negative 2x plus 1. To get rid of my 3, I divide by 3. And it's okay that it's fractions. I know you hate them, but we're going to write this as negative 2/3 x plus 1/3. All right, now I'm going to take my second equation, which is 4x plus y equals -3. And to move positive 4x to the other side, I'm going to subtract 4x. And that gives me y equals -4x minus 3. Okay, so now they are both in slope-intercept form, and I have y equals -2/3 x plus 1/3, and I have y equals -4x minus 3. Now, if you notice, let's look at their slopes. That's what's in front of the x. -2/3 and -4 are not the same slope, and positive 1/3 and -3 are not the same y-intercept, so these are two very different lines. Since they are different lines, they are going to intersect at one point, and this is an independent system. Example 5 is our last example, and again we are trying to classify this without graphing, and I want you to tell me, is it independent, is it dependent, or is it inconsistent? So example 5 is pretty easy because if you notice in this first equation it's already in slope-intercept form. I have y equals 2x minus 3 already. So all I have to do is I need to take my second equation, which is, it would help if I had my pen out, 6x minus 3y equals 9. So to move positive 6x to the other side, I subtract 6x. And that leaves me with -3y equals -6x plus 9. And then to get rid of my -3, I divide everything by -3. So that gives me y equals, a negative divided by a negative is a positive 2x. 9 divided by -3 gives me -3. And I'm just going to rewrite my first equation so that way they're closer to each other and we can compare them. So let's compare their slopes. They're both 2. Now let's compare their y-intercept. They are both -3. So I hope that you notice that these are the exact same line. They both equal 2x minus 3. So since they are the same line, this is a dependent system.